Welcome to Theory of Computation. Here I am going to give an explanation for the few properties of recursive, recursively enumerable and not recursively enumerable properties. So if you consider property, here union property, union of two recursive set is recursive. So it is already proved in Unit 2 under recursive languages. So we already discussed the union, intersection, complement and the reverse of recursive language is recursive. The same notation can be used, but here we should prove that property by using Turing machine. So you can able to solve this problem either with using second unit concepts or you can use Turing machine here. So here I am going to explain this proof with the help of Turing machine. So if you consider M1 as a Turing machine which accepts a language L1 and W is a string which is accepted by the machine M1 means it produces S output, otherwise no output will be produced. So if it is no, this string is rejected by that language. The same input string W is given to the machine M2. It is another Turing machine and that Turing machine supports another type of recursive language L2. So if the same W is accepted by M2, it will produce yes, otherwise it will produce no. So these are all independent Turing machines. So if you combine these two Turing machines, that means union. So how can we prove it? So first the input language L1 with the given input string W. So W is given to the machine M1. If the machine M1 accept W, then it will produce S as an input, the S as an output. So if the machine M1 produce S means that W should be accepted by L1. Suppose if it is rejected by M1, the output is no. So the same W should be given to the machine M2. If the machine M2 accepts that language, it will produce yes. Otherwise, it will produce no. So if you check the final output of M2, if the W is no at machine M2, the same W is not accepted by M1 also. So this is the notation. So if you consider W, it is not accepted by M1 means it should be given to machine M2. Suppose the machine M2 does not accept the same W means it will also produce no output. So if W does not accept means both L1 and L2 not accept that language. So union of two recursive set is recursive. So this is the proof for the first property. The same thing for the second property, you can implement the union concept also in recursively enumerable set. So I already give the diagram for recursively enumerable. If the string W is accepted the machine, it will go to S state. Otherwise, it will be available in an infinite loop state. So this is the notation. So if any looping state is available, that string is not accepted by L1. The same thing is for machine 2 also. So these are all independent Turing machines. So how can you merge these machines means the same notation. So if you consider W is given to machine M1. If it is accept means it will go to S state. So if the machine M1 give S output means that string is accepted by L1 language. So here we consider L1 is the recursively enumerable language. If it is not accepted means the machine will go to infinite loop. So we cannot able to give that output to the input of M2. Instead of that, the initial input W is given to M2 and also we try to check the same W in machine M2. If it is accepted by M2 means it will go to S state. Otherwise, this is also in looping state. So how can you check the looping state? If the machine comes to looping state means the same W is not accepted by M1 and also not accepted by M2 machine. So the union of to recursively enumerable set is also recursively enumerable. So this is the second property. And third property, complement of recursive set is recursive. Complement means if the string is accepted by machine M, and if you consider M dash, here M dash is the complement of M. So if W is accepted by M means it will not accepted by M dash. If W does not accepted by M means it will be accepted by M dash. That is the complement. What is the complement? 0 means 1, 1 means 0. So this is the complement. If you consider W, W dash. The same thing for machine M and M dash. So M output does not accepted by M dash, and also M reject values are accepted by M dash. So this is the complement. So the same thing will be specified in a diagrammatical way. So here we considered a W is a string which is given as an input to machine M. Either it will accept it, otherwise it will go to non-accepting state. So if you consider L, L is a recursive value. So recursive means it will give either yes or no format. If the machine M accept this string means M dash is the complement of M, so it will go to no state. So M dash is a complement of M. So if W is accepted by M, it will not accepted by M dash. If W does not accepted by M, it will be accepted by M dash. So this is the complement. So the complement of two recursive set is also recursive. And this is the fourth property. Consider L and L dash are recursively enumerable, then L should be recursive. So how can we prove it? Here L dash, instead of that I am using L dash means L and L dash are complement. L dash is the complement of L. So for that I am designing M bar or M dash. So if W is a string which is accepted by M means it will go to S state. So it is a recursively enumerable notation. Otherwise it will go to looping state. The same notation is available. Here it is accepted by L. So if it is a complement means it will not accepted by M dash. So it will automatically go to looping state. So recursively enumerable means the output of the machine either S or looping. So consider L bar. So here this machine M and M bar is the complement of M. So if the same input is given to M and M dash, one system accept that particular state, other one will reject it. So if W is accepted by machine M, it will go to S state. Complement means if the machine M will give S state means automatically complement of M should give no output. That is the complement, isn't it? First machine yes means second machine no. First machine no means second machine yes. So if you consider the output should be in yes no format. If any output is in yes no format, then that particular language is called as recursive language. So if you consider L and L bar are recursively enumerable, then the language L should be in a recursive format. So these are all the 4 different properties which are relevant to recursive and recursively enumerable languages. Thank you.